What I would like to do with you is the problem 5a. We're looking for a Taylor polynomial, really a Maclaurin polynomial at x is equal to 0. And our function is e to the x squared. So let's get busy taking derivatives. I'm going to do more than they ask for, just because I kind of want to make a point. So we're looking at this at 0. So f of 0 is just 1. Our first derivative, we need to use the chain rule. So we're going to have 2x e to the x squared. And the value of that function at 0 is 0. The second derivative, we need to use the product rule. So we have the derivative of the first times the second plus the second, the derivative of the second, times the first. And when we clean that up, that's going to give us 2e to the x squared plus 4x squared e to the x squared. And when we plug 0 into this term becomes 0, so we're just left with the 2. Third derivative. Well, the derivative of 2e to the x squared is 2e to the x squared times 2x, chain rule again. I have to use the product rule for this second monomial here, so I'm going to take the derivative of the first is 8x times the second plus the first times the derivative of the second. Tidy that up a bit. So it looks like we have, let's see, that's 4x and 8x. So we have 12x e to the x squared plus 8x to the third e to the x squared. And when we plug 0 into that, it gives us 0. So our third derivative at 0 is 0. I'd like to take the fourth derivative. And again, I have to use product rule in both situations. So I have the derivative of the first times the second plus the first thing times the derivative of the second. That. Now I'm going to handle this 8x to the third. I have the derivative of the first, 24x squared, times the second, plus the first times the derivative of the second. And I'm going to tidy that up again. So we have 12e to the x squared. We have 24x squared e to the x squared. We have, another 24x squared. So let's make that 48. (24x squared). And we have 16x to the fourth e to the x squared. And if I plug 0 into my fourth derivative, I get 12. So I'm going to stop right now. My fourth degree polynomial is going to be 1 plus, we don't have any linear terms, but we're going to have, let's see, 2 divided by 2 factorial x squared. No cubic terms, but then we're going to have plus 12 divided by, this is my fourth, so 4 factorial x to the fourth. And if I clean this up, this just becomes 1 plus x squared. Let's see, 4 factorial is 24, so I have plus 1/2 x to the fourth. I'm going to keep on going with this just to make a point. My fifth derivative is going to give me, well, the derivative of the first is going to give me 12 times 2x e to the x squared. As far as my second term is concerned, I need to do product rule again. So the derivative of 48x squared is 96x times the second plus 48x squared times 2x e to the x squared. The last thing, I also need to use product rule, so that's going to give me 16 times 4 is 64, x to the third times the second e to the x squared plus the derivative of the second, 2x e to the x squared times the first. So we are left with 24x e to the x squared plus 96x. So 24 and 96, I'm just going to combine them. That's going to give me 120. So I have 120x e to the x squared, right, that and that. I have 96 x to the third, e to the x squared. I have, oh, and 64, goodness gracious, so that's going to give me 160. And then I have plus 32 x to the fifth, e to the x squared. And if I plug in 0 for x, that's going to give me 0. When I go to get my sixth derivative, what I know is that the derivative of the first part here is going to give me 120 times my second, which is going to give me e to the x squared. That's not going to be 0. When I do the derivative of the second times the first and plug in 0, that's going to be out of there. Same thing for this, out of there, same thing for this. So what I know is that my my sixth derivative at 0 is 120. So when I add that, I'm going to have plus 120 divided by 6 factorial. I'm going to have x to the sixth, and 6 factorial, let me just work this out. 6 times 5 times 4 times 3 times 2. Let's see, 6 times 5 is 30, and 30 times 4 is 120. So this gives me 1/6 x to the sixth. And here's the observation. So after all of this, here's one thing I could have done. I know that the expansion for e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial, x to the fourth over 4 factorial. And we can use substitution in finding Maclaurin. So if I'm looking for e to the x squared, all I need to do is plug in x squared any place I had an x. So this becomes 1 plus x squared over 2, x squared over 2 factorial, x squared cubed over 3 factorial, x squared to the fourth over 4 factorial. So this just ends up being 1 plus x squared plus x to the fourth over 2. This is x to the sixth over 6, which is exactly what we have.